Okay, welcome back, college algebra students. We are ready to take a look at our next section in our practice block, and that is factoring. Let's go to town because we know we're going to be factoring like crazy this entire semester. You will literally factor almost every single class session, which is wild. So you want to make sure that you are on point, that this factoring stuff is a no-brainer. So let's take a look at a bunch of let's take a look at a bunch of problems and see how you do. Okay, first things first, I've already given you the rules for factoring. As a quick reminder, step number one, if you have a GCF or a leading negative, you have to factor that out. Then you factor according to the number of terms. If it's a binomial, it could be one of these three options. The difference of two squares, which would be factored like so. The sum of two cubes, here's our factored formula, or the difference of two cubes, and here's our factored formula. Now, if it's a trinomial, where my leading coefficient is equal to 1, I'm going to use trial and error. But if my leading coefficient is greater than 1, I'm using AC grouping. Lastly, if it's a 4-term polynomial, we'll simply factor by grouping. And then remember, you always have to check to see if you can factor further, because if you can, it's possible one of these techniques will work again. Okay? All right, let's take a look at number 1. We have x squared minus 7x minus 18. I do not have a GCF. I do not have a leading negative. Okay, cool. I have a trinomial. My leading coefficient is equal to 1. So that means I'm going to use trial and error. With trial and error, we're still going to multiply a times c. I'm still going to follow that step. So we have 1 times negative 18 is negative 18. And now I need to find factors of AC that combine through addition or subtraction to give me B. Right? That's what I'm looking for. And B in this case is a negative 7. So let's go through the factors. We have 1 and 18. By the way, because my B term is negative 7, that means the larger factor has to keep that negative. But 1 minus 18 is a negative 17, so that doesn't work. 2 times 9, make sure that negative is with the 9. 2 take away 9 is a negative 7, so here are the two factors. Now, because this is trial and error, all I have to do is write this in my factored form. X squared breaks down into x times x. There's no other way to get an x squared unless you take an x and you multiply it by another x. These are the two factors that when I multiply give me negative 18, and when I add give me negative 7. So it's a positive 2 and a negative 9, and guess what? You're done. If you did a quick check, you'll see you will have x squared. Remember, you're just distributing. You start with your x and you distribute to each term in the second parentheses. Once you're done with this x, then you move to the 2 and distribute to everything in the second parentheses. You're just distributing. So we have x squared minus 9x plus 2x minus 18. Combine like terms. And there it is. We know that we're correct. Cool. Number 2 is the exact same way. Consider no GCF, no leading negative. My leading coefficient is 1, so it's trial and error. I'm going to move through this one a little bit quicker. I'm still going to write trial and error. This is a great time to pause the video and try this problem on your own. A times C is 63. We want factors of 63 that combine to give me a negative 16. That's what I'm looking for here. So 1 and 63. Now here's the interesting piece. I need to get a positive 63 when I multiply them, but then when I add, I have to get a negative. Well, guess what? There's only one way that that's going to happen, and that is if both factors are negative. Negative times a negative is a positive. Negative plus a negative is a negative. Cool. We see very easily that these factors do not give me a 16. Well, we've got 3 and 21. Both of these are negative. That won't work. Let's go ahead and check some other factors. How about 7 and 9? Both of these are negative. Negative 7, negative 9. When I multiply these, I get a positive 63. And when I add these, I get a negative 16. Those are my two factors. So we're going to go ahead and put these in parentheses. P squared breaks down into P times P. And then, of course, we're going to introduce those two factors, and we are done. Remember to check your answer, but for the sake of time, I'm going to continue going. Just distribute, you will get the original. Number 3, look for a GCF. Oh, wait a second. They both have a K so that we can actually factor out. So that's definitely part of my GCF. And then notice I have a leading negative. So I'm going to factor out a negative K. Once I factor out a negative K from both terms, that's going to leave me with 7K. And then, of course, remember, you're dividing out your second term by a negative K, which means that sign has to flip. Double check. Negative K times 7K is negative 7K squared, and negative K times a negative 9 is a positive 9K. Can you factor that further? No, absolutely not. So you are done. So all we used here was GCF and leading negative. Cool. Let's go ahead and turn the page. For number 4, again, let's take a look. I look at all three terms. I definitely do not see a GCF. However, my leading term is greater than 1, and I do have a trinomial. So now I'm using AC grouping method. Cool. AC grouping is really great. The name tells you exactly what to do, right? First things first, A times C. So 7 times negative 20 is going to give me negative 140. I need factors of negative 140 that give me a negative 31. That's what I'm looking for. So let's go for it. 1 and 140, the negative has to go with a larger factor. Because we have a negative 140, we know we need a positive times a negative to make a negative. We have 2 times 70. Well, that one's not going to work. Let's go ahead and take a look. We know that we can do 5 and 28. Let's check 4 real quick. I don't think that 4... Yep, 4 and 35. There it is. I almost skipped it. That would have been a bummer. 4 and 35, and negative with the 35. 4 take away 35 is negative 31. So guess what? These are my factors. Now, this is different from trial and error. When you group, you need to have 4 terms. But I only have 3. So consider the fact that 4 minus 35 is negative 31. That was the whole point, right? So what we're going to do is we're going to drop this term and replace it, keeping the m, with these 2 factors. So this is what it would look like. We're going to keep the 7m squared. I could write plus 4m minus 35m minus 20. Or I could put the negative 35m right next to the 7. I'm going to do that because then it's easier to pull out a GCF, and I like it better. So I'm going to write minus 35m, then plus 4m, and then minus 20. I want you to notice that 7m squared minus 31m minus 20 is the exact same thing as this expression here. And that's because you see the first and the last term, cool. And then notice when you combine these two, you get the negative 31m. So we totally didn't do anything wrong, okay? This is perfect. It's the exact same expression. But now that I have 4 terms, I can group. So I'm going to group these first 2 terms and then these last 2 terms. If we focus on just these first 2 terms, we notice we have a GCF. We can factor out a 7m. You have to look at both the numeric and the variable part. So if we factor out a 7m from both terms, that's going to leave me with m minus 5. Double check. 7m squared minus 35m. Perfect. If you take the GCF out of the first group, shouldn't you do that to the second group? You got to be fair. So for our second group, notice that my GCF is going to be a positive 4. If we factor that positive 4 out, by the way, you need that sign there. If it's a negative, it'll be a negative here as well. If we take that positive 4 and we factor it out of both, that's going to leave us with m minus 5. Now, the cool thing is, notice the m minus 5 is identical in both terms. So my first term, my second term, they both have that factor of m minus 5. So I'm going to factor m minus 5 out, right? It's like taking it out of both terms. And if you remove them out of both terms, that leaves you with 7m plus 4. And that's your final answer. I want you to consider really quickly what happened. We went from 4 terms to 2 terms to 1 term. So 4, cut it in half, 2, cut it in half, 1. And we're looking for 1 term, okay? A product of factors. Cool. Number 5 is the same idea moving from this point. So notice with number 5, I've given you 4 terms. That means we can actually go right into factoring by grouping, which is the same when you prepared that trinomial. It's the exact same idea, but we had to prepare our trinomial for this. And now I've actually given it to you. So great time to pause the video, okay? And then come back. Let's isolate the first 2 terms and isolate the last 2 terms. For my first set of terms here, right off the bat, the x's are jumping out at me. But then I'm going to notice, I can actually factor out a 4 from both of these. So my GCF is 4x. If I divide a 4x out of each of these terms, that's going to leave me with 3y and then minus 7. Double check. 12xy, negative 28x. Beautiful. Out of these last 2 terms, my GCF, it's jumping out at me. That's definitely a 5. But keep in mind, that's a leading negative, right? Because I'm looking at just these 2 terms. So I have a leading negative. So I'm going to factor out a negative 5. And if I do that, divide each term by a negative 5, that's going to leave me with 3y minus 7, which, by the way, has to be the same. So if you feel confident about this side, you can rewrite it and be like, I'm pretty sure I'm right. You can distribute, double check that, and make sure that, yes, this looks good. The 3y minus 7 is our GCF. So we factor that out, and that leaves us with 4x minus 5. As always, check to see if you can factor further. You can't, and that is your final answer. For number 6, we get into this cool territory of, hey, now we have the difference of 2 cubes. That p to the 3rd power, just seeing the 3rd power screams cube. Not always, though. You have to take a look at the other term and see what's going on there. But this definitely is simply the difference of 2 cubes. Okay, with that being said, the first thing we should do is think, what was it before it was cubed? So what I like to do is I like to write what it was before we actually cubed it. So p was by itself, right? It was hanging out, and then all of a sudden it was cubed. Okay, cool. But what about the 8? Well, 8 was a 2 before it was cubed. And you can test this out. 2 times 2 times 2, that's definitely going to give us 8. With that being said, we can now plug into our formula for the difference of 2 cubes. As a reminder, the formula is a minus b times a squared plus ab plus b squared. Okay, remember the difference of 2 cubes will follow this format, a cubed minus b cubed, difference minus, same thing. These are 2 cubes. And then when it gets factored, it's going to be 1, 1, 2, 2, 2, because 1 and 2 make 3, right? And if we actually distributed this, you would see your inner terms would cancel, and you'd be left with a cubed minus b cubed, which is actually pretty cool. Distribute and check it out. Now, your A in this case is P, and your B in this case is 2. And that should actually make sense. If you want, I can even write it directly above so that you can see A is P and B is 2. So everywhere we have an A, we're going to replace with a P, and everywhere we have a B, we're going to replace with a 2. So let's check it out. So in my first parentheses, I'm simply going to have P minus 2. And then in my second parentheses, I'm going to have P squared plus, and now I'm not going to write P2. That's just silly. P times 2 is 2P. Make sure that you're thinking about what it is that you're doing. And then B is 2, so 2 squared is 4. I'm not going to leave it 2 squared because we can actually do the math. So you always want to make sure you're simplifying that. At this point, once you've factored the difference of 2 cubes, you're done. This will never be factorable. That's the beauty of this, okay? Once you've used the formula, you're done. You can move on. Very nice. So far, so great. Let's take a look at this last problem on this page. We have 4p squared minus 25. This time, notice that 4 is a perfect square. P squared is a perfect square, and so is 25. So immediately I say, do I have a GCF? No, but this is definitely the difference of 2 squares. As a reminder, that looks like a squared minus b squared, and then when we factor it becomes a plus b times a minus b. And all we want to do is say, what was it before it was squared? So this might be helpful again. What was 4p squared before it was squared? Well, 2p. Because 2p times 2p is 4p squared. And then what about 25? What was it before? It was a 5. Because 5 times 5 is 25. And now I can fill this in. A's are 2p's and b's are 5. So my final factored form, I fixed it. 2p plus 5 and 2p minus 5. That's it. That's literally all you have to do. These are not factorable anymore, so we are done. Ooh, I hope this is all coming back to you. Let's turn the page. This is another great time to pause the video and try this out on your own. Number 8, first step is GCF. I'm looking at this and that B is jumping out at me. So I'm going to take B and factor it right out. That leaves me with 3b squared minus 5b plus 2. Now, I'm not done. Notice I have a trinomial inside the parentheses. So the first thing I did was GCF. That's cool. But now I have a trinomial whose leading coefficient is greater than 1. I got to use AC grouping. And because I don't have a ton of space here, I'm actually going to bring this trinomial over here. And I'm going to work through the process of AC grouping over here. That way I don't clutter up my space. So we're going to start with a times c, which is a positive 6. And I need factors of positive 6 that give me a negative 5. So 1 and 6, both of them have to be negative. Remember, it's a positive 6, so they have to be the same sign. But this won't work. Negative 1 and negative 6 give me a negative 7, not a negative 5. But we also have 2 times 3. If we make both of those a negative, negative 2 times a negative 3, there's my 6. Negative 2 minus 3, there's my negative 5. So those are my 2 factors. So let's rewrite this. Again, I'm going to put that negative 3 closer to the 3b squared. So we have 3b squared minus 3b minus 2b plus 2. Okay, that negative 5b gets dropped and replaced by the 2 factors that we found. These are the exact same expression. They shouldn't be different at all, other than the fact that you're replacing that negative 5b with these 2 terms. Okay, now I'm going to go ahead and group, right? AC grouping tells you what to do. First 2 terms, last 2 terms. Out of the first 2 terms, I'm going to take out a 3b. That leaves me with b minus 1. Out of the last 2 terms, I'm going to take out a negative 2. Remember, leading negative. And that leaves you with b minus 1. If that's tripping you up, double check. 3b squared minus 3b, negative 2b plus 2. Now we're going to take that b minus 1, we're going to factor that out, and that leaves me with 3b minus 2. This answer that I have here, I'm going to go ahead and replace this trinomial with this factored form. So that means my final answer is b times b minus 1 times 3b minus 2. And that whole thing is my answer. Yes, excellent. We have 2 more problems that are very similar. Again, pause the video, try these last 2, come back, and let's take a look, see how it went. All right, we definitely have a GCF this time, and we have a leading negative. So I'm going to factor out negative 5. It's going to be helpful. Take your calculator, double check to see what you're left with when you divide that negative 135 by the negative 5. So we are left with, in parentheses, x cubed plus 27y cubed. Super cool. On the side here, I'm going to write a cubed minus b cubed as a reminder, and then my factored form, a minus b times a squared plus ab plus b squared. 1, 1, 2, 2, 2. I love it. Notice the signs are the same, then this is the opposite sign, and then this one's always positive. It follows that nice acronym SOAP that will always help with your signs. So same, opposite, always positive. Think a cube of soap, okay? A cube of soap. Before x was cubed, it was, well, before we had x cubed, we had just x, right? That's what it was before it was cubed. And then 27y cubed before it was cubed was a 3y. So using these bits of information, and maybe you can circle it if you want, maybe that's helpful. We're going to replace every a with an x and every b with a 3y. Let's go for it. A is x, b is 3y. A is x times x is x. X times 3y is 3xy. Oops, I forgot the square here. Ha, I'm getting sleepy. So x to the second power is x squared plus, and then a times b, x times 3y is 3xy, and then plus b squared. Please be careful. That just means 3y times 3y. And if you take 3y and you multiply it by itself, you get 9y squared. That's super important. Don't forget we had a negative 5 in front. So my final answer is negative 5 times x minus 3y times x squared plus 3xy plus 9y squared. And that is your final answer. So fun. 1 more problem to go. This is amazing. First things first, GCF. Okay, I'm going to write that in here. Sorry, I didn't write GCF here, but you know what I was doing. And then if you want, you know what, I'll write difference of 2 squares, 2 cubes, excuse me. I kind of wish that were a positive. I'm bummed out. It was. Oh my goodness, what is happening here? So I made a huge mistake. This was x cubed plus 27y cubed. This is the sum of 2 cubes. What is happening in my brain? I really should just like use a little eraser thing that I have. But you know what? It happens. We're only human. Mistakes happen. No big deal. This is going to be a plus. Same sign. This one should be a negative because it's opposite. And then this one's always positive. So I can hear you guys being like, oh my goodness, I can't believe she did that. You know what? It's okay. It happens. So x plus 3y, and then that should be a minus right there. So my bad. I totally made that mistake. This is a sum of 2 cubes, plus minus plus, same, opposite, always positive. Double checking. Whew, I feel a lot better about that. Okay, now that I totally fixed my mistake, let's go for it. Okay, we're going to factor out that 2 That's first. That leaves us with x to the fourth minus 16. So we started with GCF. Now, I definitely notice that this is a perfect square, and so is this one. Before it was an x to the fourth, it was x squared, right? Because x squared times x squared is x to the fourth. And then before it was 16, it was a 4, because 4 times 4 is 16. So we're going to use the difference of two squares formula. And that is where you have a squared minus b squared, and that factors into a plus b times a minus b. Okay, cool. So that means we have x squared plus 4 times x squared minus 4. I'm going to bring the 2 right over so I don't have to rewrite it. Ooh, I'm actually not done though. Notice the 2, totally fine. X squared plus 4, can't factor that further. I only have the difference of two squares, not the sum of two squares. But then notice I have x squared minus 4, which is again the difference of two squares. So this factor here, again, difference of two squares, which is kind of crazy. So we'll leave the 2, we'll leave the x squared plus 4, and now we're going to break this up. Okay, x squared minus 4, when we factor, becomes x plus 2 and x minus 2. And that is your final answer. Thank you for bearing with me, especially on that problem number 9. Hey, we fixed it, no big deal. Hopefully everything goes well for you while you're doing your factoring. Again, if you need any help, don't hesitate to reach out. You got this. Make sure you're mastering factoring, and I'll see you next class. Bye.